Brought to you by Davies Paint Philippines Incorporated.
Our media partners, SparkUp.
Our community partners, Bataan Peninsula State University Society of Mechanical Engineering Students, Junior Philippine Society of Mechanical Engineers, Cavite Chapter, Junior Philippine Society of Mechanical Engineers, De La Salle University, Dasmariñas, Junior Philippine Society of Mechanical Engineers, Don Mariano Marcos Memorial State University, Bidlo Union Campus Student Unit, Junior Philippine Society of Mechanical Engineers, Emilio Aguinaldo College, Cavite, Junior Philippine Society of Mechanical Engineers, Maragondon Branch,
Junior Philippine Society of Mechanical Engineers, Polytechnic University of the Philippines, Alfonso Campus, Junior Philippine Society of Mechanical Engineers, USTP Chapter, Junior Philippine Society of Mechanical Engineers, Xavier University Chapter, Philippine Society of Mechanical Engineers, Technological Institute of the Philippines Student Unit, Manila, Philippine Society of Mechanical Engineers, Technological University of the Philippines Student Unit, Philippine Society of Mechanical Engineers, Camarines Norte State College Student Unit,
Philippine Society of Mechanical Engineers, Colegio de Muntinlupa Student Unit, Philippine Society of Mechanical Engineers, Bicol University Student Unit, Philippine Society of Mechanical Engineers, Lyceum of the Philippines University, Cavite Student Chapter, Philippine Society of Mechanical Engineers, National University Student Unit, Philippine Society of Mechanical Engineers, Pamantasan ng Lungsod ng Maynila Student Unit, Philippine Society of Mechanical Engineers, Pangasinan State University Student Unit,
Philippine Society of Mechanical Engineers, PUP Student Unit, Philippine Society of Mechanical Engineers, Sorsogon State University Student Unit, Sorsogon Chapter, Philippine Society of Mechanical Engineers, Tarlac State University Student Chapter, Philippine Society of Mechanical Engineers, University of Batangas Student Chapter, UP Geodetic Engineering Club, and a special thanks to UP Mining Metallurgical and Materials Engineering Association Incorporation.
I am Nathaniel Beaver A. Mendoza from St. Louis University. I am here to cheer and encourage our next board exams takers. Alam ko, marami dyan ang natatakot, nagdadalawang isip, napanghihinaan ng loob. I would like to say that all of those are valid. Totoo yan, naranasan ko rin yan nung una. But, don't let it eat away all of your time. Walang mangyayari kung palagi tayong magpapaanino sa mga negative thoughts natin. Kailangan nating kumilos and make the best of our time if you really want to succeed. Don't wish for it, make it happen. O kaya, nasa Diyos ang awa, nasa tao ang gawa. Kung tips sa review ang kailangan nyo, sabi ko, magkaroon kayo ng time management. Si Prime kasi araw-araw yung may lecture, araw-araw may isosolve, yun. Huwag rin kayong sana ma-overwhelm sa program ng Prime. Kasi talagang kailangan yan. Marami pa sana akong gustong sabihin, pero I leave that for you to discover. Lalo sa techniques, tuturo yan lahat ng Prime sa inyo. Magaling silang magturo. So anyway, gusto ko sanang magpasalamat sa pamilya ko, sa kanilang walang tigil na suporta, sa SLU ME Department at Prime Review na ibinuhos lahat ng knowledge at wisdom sa amin para mapagtagumpayan itong board exams. And most importantly, kay God na nag-guide sa atin. Thank you, God bless, lakad matatag.
Ako po si Christian Justin Sese, and I'm here to tell you how did I manage to get here even though na pandemic tapos puro online po yung review natin. Marami pong factors na consider, and malaki pong factor talaga na tumulong is yung Prime Review Center with the help of LearnHub PH app. As we all know, sobrang dami kailangan pagkaraan sa board exam. And from experience, so as much as possible, memorize mo lahat ng formulas, concepts, and elements. But Prime Review Center was able to cover this. We were able to tackle these major concepts, elements, and formulas in a very systematic pacing. Tapos, yung mga calculator techniques, shortcuts na formulas in different kinds of subjects, natutunan ko lang sila dito actually. Pero yung Prime Review Center talaga, binigay nila, hindi sila selfish. We also notice yung mga videos na ina-upload nila sobrang detailed. Like, matututo ka talaga. Like, step-by-step solution, ibibigay nila. Yung mga problems na sobrang hirap na parang ang dali lang kapag sinolve, ibibigay nila. Yung pag nakakita ka ng ganitong problem, paano isosolve to, anong unang gagawin, di-discuss nila kung paano. Yung mga shortcuts, tips, and kung paano isosolve yung ganitong problem, di-discuss din nila doon. And kikita mo talaga na yung mga instructors and teachers na nagtuturo doon sa voiceover ng video, experience talaga. And sobrang dami namin natutunan sa kanila. And Prime Review made this possible, and we are very grateful kasi bumibilis kami mag-solve na dati parang 5 minutes per problem, parang 2 minutes na lang ngayon or 1 minute even. Sundan yung program ng Prime. I was able to make it. Kaya we are very grateful for them teaching us.
Ang ating pong review ay online. At kung tayo man po ay may pangamba dahil dito, sana po alisin natin ang anumang pag-aalinlangan sapagkat si Prime naman po ay ibibigay lahat ng ating kailangan para tayo ay maging handa sa darating na eksaminasyon. Ganyan din naman po ako nung kami ay nag-review ng online na may pag-aalinlangan. Ngunit sa awa ng Diyos, sa tulong ng Prime, at sa pagsisikap, tayo po ay nakapasa. Which is, yun naman po ang gusto nating lahat. So, magtiwala lang po tayo and do our very best during the review. At tinitiyak ko po sa inyo na after ng ating review and refresher dito, ay sapat ang ating kakayahan para sa ating darating na board exam. Good luck, God bless, and have a nice day.
Okay, so good day sa inyo lahat. Ako pala si Engineer Marvin Ferrer, ang top 4 ng last Mechanical Engineering Board Exam which was held noong August 2021. And andito kami para ibahagi sa inyo yung mga kung paano nakatulong itong si Prime Review Center na yun nga dahil sa pandemics, nag-online review na lang tayo ngayon. So unang-una dito is napaka-flexible ng pag-review. Kung gusto mong mag-review ng gabi, pwede. Kung gusto mong mag-review sa Starbucks, pwede. Kasi pwede mong i-download or kunwari, basta may wifi ka, pwede mong panoorin at sagutan yung mga assessment, mga videos, anytime, anywhere na gusto mo. Besides dito, syempre, napakarami mga formula, mga elements na kayo may memorize, diba? Dito, bibigyan ka rin ng mga tips and tricks, mga techniques kung paano mas ma-memorize yung mga kailangan mong kabisaduhin, mas may-retain itong mga to. Mga index card, diba? Ayan. Dahil nga di sa Prime is, hindi lang ako naging engineer, naging top 4 pa ako, top notcher, diba? So, yun, napakalaking tulong talaga ng Prime Review Center na ito, kahit na pandemic. Thank you ulit sa Prime, and napalaking tulong nyo, and sana mas madami pa yung matulungan na magiging soon-to-be engineers, and thank you sa pakikinig, and ingat kayo.
Magandang araw po sa ating lahat. Ako po si Engineer Emmanuel Villasin. Unang-una po, gusto pong pasalamat sa Prime Review Center sa pagbibigay po ng tulong at suporta sa ating mga future mechanical engineers. Para po sa mga mag-review pa lamang at mag-take pa lang po ng board exams, ang masasabi ko lang po is review smarter, not harder. Kailangan po muna nating alamin yung mga weaknesses natin bago po tayo mag-focus sa other topics. At since online review nga po ito, kailangan po natin magkaroon ng disiplina dahil wala po nagbabantay sa atin sa bahay. At kailangan po natin maglaan ng enough time to review. Sabihin na natin around 2 to 3 hours a day na pagsusolve po ng dire-diretso. Hiwalay po po yun dun sa assessment na binibigay po ng Prime. At huwag na huwag po tayo mag-panic dahil kapag nag-panic po tayo, meron pong chance na baka makalimutan po natin lahat ng mga na-memorize na natin. And lastly, huwag po natin kalimutang magdasal at humingi ng guidance. Yun lamang po, good luck sa ating lahat, and God bless po.
So hello po sa inyong lahat, sa mga future engineers out there. Ayan, so today gusto ko lang kayong i-inspire, i-encourage at magbigay na rin ng ibang tips na nagamit ko sa pagre-review. And so siguro marami sa atin dyan naninibago at nag-a-adjust pa sa online setup ng review. Ayan, pero huwag kayong mag-alala kasi it really works, guys. Yung program ng Prime, kita naman sa amin, mismong byproduct kami ng program na yan. And so, tsagain lang natin, talagang sundan din natin yung mga advice ng mga lecturers natin. So, yun yung unang tip. Sundin natin yung mga advice nila, like pagsulat sa index card, repetition ng formulas, and also mnemonics. Sobrang mahalaga na, laking tulong sa akin yan, promise. And also, tsagain natin yung mga 100 problems every day. May mga problems talaga na hindi natin alam i-solve, pero huwag kang madi-discourage kasi the next day, may solution naman. Aralin na lang natin yun. And then, lalong-lalo yung mga assessments, guys, tsagain natin yan. Tsinaga ko talagang finish ko na aralin lahat ng hindi ko alam i-solve. Sinulat-sulat ko lahat yan. Inulit-ulit ko. And eventually, ayan, it really helped me a lot. Nakapasa naman tayo and nakaabot pa sa top 10. Ayan. So, talagang diskartehan lang natin yan, tsagain. And also, pinakamahalaga is araw-araw na manalangin, humingi ng tulong kay God. And bibigyan niya naman tayo ng strength and ng wisdom. Basta humingi lang tayo sa Kanya. Ayan. So, hopefully, na-inspire kayo doon and sana makatulong. Sabi nga nung isang great philosopher, pag may goal ka, focus, success. Ayan. So, God bless po sa inyong lahat.
Good day everyone. I'm Engineer Dinglasan. Recently, nag-top 9 sa Mechanical Engineering Licensure Exam last August 2021. First of all, let us thank the Lord for this opportunity na binigay niya sa atin na makapag-review at makapagbigay ako sa inyo ng konting advices lang sa inyong mga review classes. So, kung kayo ay napapagod, natatakot, nangangamba, kung worth it ba ito through the end, syempre yes, magiging engineer ka sa dulo eh. Masaya kaya maging engineer. Tapos, yun nga, every hardship ay merong kapalit na maganda sa dulo. Gusto ko lang kayo iwanan ng konting Bible verse from Philippians chapter 4 verses 13. I can do all things through Christ who strengthens me. So, kung ikay nangangamba, napapagod niya, napapagod, tinatamad, nandiyan lagi si Lord para gabayan tayo. Ako, talagang huminga ako ng kay Lord, ng encouragement, talagang huminga ako kay Lord ng dasal ako ng dasal sa throughout review, through the board exam, kahit yung board exam itself. After the board exam, talagang nagpapasalamat ako kay Lord na ginabayan niya ako talaga. Kaya yun, kailangan nyo lang talaga ng seek guidance through the Lord. Huwag matatakot. Good luck and God bless. Stay safe po sa atin. Thank you very much.
Passing the board is one of the greatest achievements that an average person like me can achieve. Topping it is a dream that only few gets to achieve. I myself never thought I'd be in this position, yet here I am. With passion to engineering, I get to boost my morale despite all negativities. With hard work and perseverance, I get to challenge myself and know my weakness and capabilities. With prayer, I get to know myself and what kind of engineer would I become. Magiging mechanical engineer ako. Claim it and receive it by faith. This what kept me going through the journey of becoming the top 10 of the August 2021 Mechanical Board Exam. At basta, magtitiwala ka lang sa mga turo ni Prime.
order one of your very own Peace Merch shirt. And now, are you guys excited to learn about what our speaker has in store for you guys today?
That was 10 out of 10 marketing. Thank you, Gab, for that. So, anyways, let's get back to the program. So, as you all know, we're all excited to learn about what our speakers have to offer. But before that, we got to introduce ourselves. So, once again, I am Ram.
And I'm your host, Gab, and together we are welcoming everyone to the National Mechanical Engineering Students Convergence 2022 Crank Up Seeing New Perspectives Day 2.
And this is brought to you by the Philippine Society of Mechanical Engineers, University of the Philippines Student Unit, in celebration of PSME Month 2022. Engage, rethinking today, reshaping tomorrow.
Yan, on to our speaker again. The second NMESC 2022 Crank Up speaker is a licensed mechanical engineer who graduated from BS Mechanical Engineering in UP Diliman. He also received a graduate diploma, NZQA Level 7, in Mechatronics Engineering from Wellington Institute of Technology. Some of his projects include robotic pan and tilt testing system for sensors, self-leveling, seaborne UAV landing pad, and a CNC Cartesian robot.
He was also recently an autonomous mobile robotics engineer in the Kerber supply chain, and he's here to talk about mechatronics and robotics industry. Everyone send some heart reacts, or if you're on YouTube, please like the video for engineer Christian Alexis Luz. Once engineer Luz has finished his talk, we will have a short break before proceeding with our Q&A. So without further ado, heart reacts or likes for engineer Luz.
All right. So, all right. Okay. So, hi there, everyone. Thanks again to PSME for having me on for this talk tonight. So, again, my name is Christian Alexis Luz, and I'll be talking about mechatronics and robotics engineering, right? So, to start off, I want to introduce the mechatronics and robotics industry in general. So, like how you would be able to enter this industry and what it's like to work in this industry. So, before we move on, I just want to define some terms. So usually there's an intersect between the words mechatronics and robotics, right? So mechatronics basically is the integration of electronics, control engineering, and mechanical engineering in order to produce products that synergizes their effects to create useful products, right? So moving forward, robotics is a subset basically of mechatronics. So all robots are mechatronics, but not all mechatronic devices are robots. So what makes something a robot? So the general consensus is robots are autonomous machines and they're capable of sensing their environments and they're able to like make their own calculations and make decisions on their own. So this implies that robots are more sophisticated forms of mechatronic devices, right? So before moving forward, I'd like to share why I chose to enter the mechatronics and robotics industry, coming from a mechanical engineering background. The first reason is that robots improve productivity. The Harvard Business Review did a study in 2015 where they measured the annual labor productivity growth rates of key technologies invented in the past several decades. So actually, based on the measurements that they did, robots contribute to productivity as much as the steam engine did back in the first industrial revolution. Like this goes without saying, that's the reason why robots are driving the third and the ongoing fourth industrial revolution. So being in this field, there's really a lot you can do to revolutionize various industries and to help a lot of people out. Second reason why I got into this field. Robots help countries or companies remain economically competitive. I came across this graph done by the McKinsey Consulting Group. It shows how labor costs have been rising throughout the years. And as you can see here in this graph, as technology improves, robot prices have been going down. So why do labor costs rise? So basically that's done by a shrinking population. When your population ages, you have less people basically available to work for you. And also wages increase. So it makes it difficult to hire more people. So what's interesting is, so given this, some countries really need to use robots to stay economically competitive. So I have a series of graphs here. This graph shows the industrial outputs of some of the biggest producers in the world. So the top ones here would be China, USA, Japan, Germany, if you count it up here. But what's interesting is when I found out about this study, I checked that China has the most number of employees in the manufacturing center, in the manufacturing sector rather. So if you compare this to the number of people employed in the manufacturing sector by USA, Japan, and Germany, it makes you wonder how the US, for example, can keep up with China, right? So if you look further studies show that for every 10,000 manufacturing employees, Germany, Japan, and the United States they employ more robots for every 10,000 employees in manufacturing companies. So this goes to show that if you want to keep up with other companies or countries in terms of their manufacturing output, you have to consider technology, particularly robots. And my third and final reason for entering this field of specialty is that the field of mechatronics challenges you to continuously learn and synthesize new concepts into something useful. So this is more of a personal reason for me. So I did take up mechanical engineering, but if you see this graph here in front, mechatronics is at the intersect of various engineering disciplines and fields. So what's really interesting about this concept is that when you get to mix so many new concepts, you get to be creative and you're able to create new solutions that haven't been done before. That's why people come up with various robots in for various applications. Like you've got self-driving cars. You have the usual robotics arms that most of us are familiar with in factories, in which they're most commonly used. Medical robots and robots for the military or defense. So it's really an exciting field with a lot of things that you can do with it. Right. So just a brief timeline of my work history. So with this section, I kind of hope to show how I got to be a mechatronics engineer, starting out as a mechanical engineer. But by no means is this the only way to get to where I'm at now as a mechatronics engineer. There are a lot of ways to get to it. So I did start off with my BS Mechanical Engineering degree, graduated in 2015. I only had one org in UP. I was part of the UP Junior Marketing Association. Afterwards, I took my first job in SunPower. SunPower is a US-based solar cell manufacturer. So I was lucky enough to join this company when they were transitioning to a more automated factory. So this was really the first time that I got exposed to automation and robotics in general. And it's where I saw firsthand like how robots transform the manufacturing industry, which robots traditionally operate in. After SunPower, I moved to a Japanese company called 𝐂𝐑𝐀𝐍𝐿. It's also a manufacturing automation company. Given my mechanical engineering background, I didn't have as much programming experience as other engineering majors did. But in this company, I got to work with computer vision systems. Basically, I program robots to identify defects on products on production lines automatically. So this is a really interesting field that's very applicable to robots as well. Computer vision. And computer vision can be a subset of machine learning and deep learning. So, but that's a very specialized topic moving forward. Afterwards, I've decided I wanted to really specialize in the field of mechatronics. So I took up further studies at the Wellington Institute of Technology in New Zealand, and I graduated in 2019. During my time there, I did projects for two technology companies. So one for scene safety and two for Xcraft, a drones company. So later on during this talk, I'll be talking about the project that I did for Xcraft because I used a lot of mechanical engineering concepts for my project there. Then lastly, my most recent work experience was for Kerber Supply Chain. So this was from 2021 to 2022. So I was an autonomous mobile robotics engineer. So autonomous mobile robots, or AMR for short. Okay. So being a robotics or mechatronics engineer, you could work in various kinds of industries. But based on this study made by the McKinsey Group again, robots find most use in industries where there are a lot of predictable, physical, repetitive tasks. So as you can imagine, all tasks in a or most if not all tasks in a factory are repetitive. Put this chip on this board at the same spot at every time. Pack this apple into this box at the same spot at every time. So robots really have an advantage in those kinds of industries. So this graph aims to show that. So just to summarize, my time in Key and SunPower, they were in the manufacturing industry. And then my time in Kerber was more of in the transportation and warehousing industry, right? So my latest experience was, again, as an AMR engineer for Kerber. So I'm quite excited about what Kerber does because they were able to set up the first AMR-based warehouse here in the Philippines. So it's the first of its kind. Like, robots are very commonplace here in the Philippines already for the manufacturing sector, but I was really lucky to be able to get to work with a company that set up the first robotic warehouse here in the Philippines. So just to give a brief background, here's the situation. So I'm sure a lot of us order stuff online, like on Lazada or Shopee, right? So what you do is you place an order. When you place an order, that order goes to a distribution center or a warehouse. And in older warehouses, what would happen is warehouse operators or pickers, so they're called, initiate the picking process. So basically, they go through all these rows of shelves in their huge warehouse and they get all the goods that you ordered and they get them one by one and put them in a cart. And then they have to do it all over again for all other orders that they have to process. So as you can imagine, it's a very tedious job and could be physically taxing for people, and it could be slow at times. Like, imagine having to look for something in all of these stacks of boxes. So that's what Kerber Supply Chain, in partnership with the Hong Kong-based robotics company, aim to address. So how do AMR systems work? Basically, instead of people going to shelves, the shelves are brought to you by robots. So as you can see here, shelves are moving around, carrying racks to workstations. So basically, when an order comes in, the system tells the robot where the particular item is located, and then it brings it over to an operator. So here's the robot picking the shelf up, and then here's an operator getting the items from the shelf. So this is said to increase efficiency by 200 to 300%. So you can imagine, by increasing the throughput of a fewer people, you can increase the overall efficiency of your delivery process. So it's a really good application of robots. So that's a quick background on a key application of AMRs. And then I just want to share like what you could expect to go through if ever you were to work in this field. So unfortunately, I can't share the floor plans of the client here in the Philippines, but it is a large retail company that that partnered up with my employers in Australia, basically. So before you even think about working with the robots, you have to set up the infrastructure in which these robots will operate in. So to start, because I started on day one on this, there was nothing. So basically what we had to do first was lead a team of laborers to build up all of these shelves to store the goods. So there were about, let's say, 900 to 1,000 shelves that are in our site here in the Philippines. And then apart from that, you might be wondering now, how do the robots navigate the space? You can't see it here, but there's a grid of QR codes stuck to the floor for every 1 meter or so. So the robots actually read those QR codes so that they know where they are in the warehouse. So they know they're underneath the correct shelf. They know they're delivering to the correct workstation, to the correct person, and the like. And it's not just seen here, there are charging stations here as well, because of course the robots need to charge. The cool thing about them is that they, just like our phones can tell us when it's below 20%. The robots know where these chargers are located and they just drive over to them when it's time to charge, right? And then a last key component of the infrastructure aspect of the project was the workstations. So this is where the pickers would be. So instead of having the pickers come in here to get items, the pickers would just have to be here and the items will come to them. So it improves the efficiency of just a fewer workers. So you get more through less, right? This is the infrastructure aspect. But what I personally find more fun is focusing on the robot itself. So this is the robot that we work with. It's designed and manufactured in Hong Kong by a company called Geek Plus, right? So a lot of parts come into to the robot. So again, mechatronics deals with electronics, computer systems, and mechanical parts. So it comes in with all of these parts. So a typical day for me would be during setup, like what I did was configured all the robots so that they could connect to the Wi-Fi network in a stable manner. Because of course, because the robots communicate with the system using Wi-Fi. But again, as with anything, things eventually break down. So troubleshooting then needs to be done. So whenever a robot has a problem, you have to diagnose it. You usually plug a laptop into it and it gives you its diagnostics. And then it tells you some clues. And like you read some clues, some error logs, and it helps you identify what the problem is. And then if you can figure it out, in general, also being an engineer, if you can figure something out, you have to be able to collaborate well. Like because all of my bosses and all of the manufacturers, they were abroad. They were either in Hong Kong or Australia. So whenever I found a problem, I had to communicate with them the issue. So technical communication is key for any engineering job, really. At that point, you'd open up the robot and change the relevant parts that caused the problem. And after that, put it back into the warehouse where it could start working again. Just so you can get an idea, this is me with one of the robots. So it's larger than a Roomba. I know it looks like a Roomba, but it's quite larger than that. This thing can actually carry a rack up to 300 or 400 kilograms. So it's quite scary to work with. You really have to be careful, and you really have to be really have to take care when you're fixing it, like everything is in place. So you really have to be precise about these things. So it was a challenging job in a way because I had to take care about me and my partner. I had someone else work with me there. We had to take care of about 130 of these robots. So it could get quite insane. Like they're all running around, and if there's something wrong with one of them, you have to chase it, you have to turn it off, you have to bring it to the side, open it up, and fix it. So it's quite fun, and it's a lot of exercise as well. So it's not always this notion that engineers or like scientists or whatever are always at their desk, that like all you do is your study. Like it's really field work also in a way. So that makes the job quite exciting. Right. So I've just talked about my work history there, but I mentioned earlier while I was studying in New Zealand, I was able to do a project for a company there while I was completing my studies. I wanted to share it here as well because I wanted to also highlight the importance of R&D or research and development to advance the field of mechatronics and robotics engineering. And I want to show like why mechanical engineering is like a significant part of this R&D process. Because a lot of people say when they say robots, oh, that's a ComSci thing. Oh, that's a ECE or electronics and communications engineering thing. I don't agree with that. I think it's really a balance between all of these fields. Like if the physical aspect were there, the mechanical aspect were there, how could a piece of software interact with the physical world? Like what we mechanical engineers can give to the field of robotics is huge. So that's why, like, hopefully after the talk, if you choose to enter this particular industry, I really look forward to that, and I do hope that you consider it. Right. So anyway, moving back, I was studying in New Zealand, and I found a company to work with as on a partnership basis. Basically, they were helping New Zealand address their environmental safety and security needs through robotics. So this is New Zealand. It's a huge island, right? And they're very concerned about the security of their country and like the state of their nature assets in the country, like how the forests are doing, how the oceans, the seas around them are doing. Because it's a country that really values the environment as well. So they need staff or people to do all of these things, like observe the weather, the climate, monitor animals, and then for security, they have to track down poachers, chase down poachers, illegal fishers, and the like. But here's the problem. New Zealand has a land area of 270,000 square kilometers. Compared to the Philippines, we're at around 300,000. So you can say it's roughly the same. But then the problem is New Zealand only has about 5 million people, their population, as compared to us, 109. We had 109 people here in the Philippines. So the question is, who's going to do it? Who's going to cover this whole coastline here? Who's going to patrol all of these forests here? And who's going to patrol the seas surrounding New Zealand, right? So that's where this company called Xcraft comes in. Xcraft is a New Zealand-based unmanned aerial vehicle and unmanned surface vehicle research and development robotics company. So they have a lot of robots that they develop themselves. So these robots are autonomous, like they can act on their own, or they can be piloted. So we're familiar with drones, so the concept's just the same. But the thing is, these robots are very customizable. Like for example, I'll just show these first two. This is their 𝐂𝐑𝐀𝐍𝐊 class USV. So basically, this boat was originally designed to bring emergency supplies to like ships that capsize or to quickly pursue illegal fishers. So that's one application. Then we have this drone here, for example. They loaded it with infrared cameras and some AI in it to be able to count wildlife that it detects out in the forests. This is particularly important for pest control, because if you have too much predator species in a certain biome, like that's not good for the whole ecosystem. So that's how they're helping out with that regard. And one of their later projects is this Proteus class ship that they have. So the main project of this ship is for fisheries protection and counting the population of fish at sea, but it can also be used for security and illegal boat detection, right? So you can see here, like robots are very versatile. You can program them to do various tasks and outfit them with various attachments or loadouts in order to specifically address certain needs. So this is where I would say the difference would be is between a robot and a mechatronic system, because technically a toaster is a mechatronic system, but it's not autonomous, it's not programmable. So if the notion of mechatronics or robotics is confusing, you can think of it as a spectrum based on how customizable something is, based on how autonomous the thing is, right? So given that Xcraft has boats and drones, sure, that's good, right? But you can't just drive out. Okay, Auckland's like one of their bigger cities. You can't just drive out here and launch a drone into a forest here. Like, that's not always possible. The roads aren't always there. And vice versa, the other end of the spectrum, boats can only explore at sea. Like, they'll only see the coastline and all of that. How could they see inland, right? So what Xcraft wanted to do was this: adopt the concept of a mini aircraft carrier. So basically, launch drones from sea, right? But the problem is, how do you land drones at sea when you have to deal with waves, right? How do you safely land drones on them? So in order to address this problem, I agreed with the client, with Xcraft, that we will design a self-leveling UAV landing pad for ships. So this is a quick render of the landing pad that I made. By the way, this was done on SolidWorks. I highly recommend, if you're also, I think most, if not all of your students right now, really take the time to learn some 3D design software, whether it's SolidWorks, Fusion 360. It's something looking back, it's something I wish that I studied earlier, because it's so useful in our industry, because we're dealing with physical things and we need to represent them effectively, right? So this is the landing pad concept that I made. And just to, okay, just let me load this up. Just to explain some terms, when a ship rolls, it turns about this axis. When a ship pitches, it turns about this axis here. So we clarified the requirements with the client. This landing pad should pitch 25 degrees if the ship pitches negative 25 degrees. And in that way, you maintain a flat landing surface, like so, right? Basically, that was the concept of the project. So moving forward, when you're starting out, you don't really have to get into the math of things yet. Like, you want to experiment, you want to iterate ideas, like you want to test out concepts that you might have in your head. So I started off with a small scale model. So this is where my electronics knowledge was tested. Like, I had to learn how to program microcontrollers, how to use gyroscopes, accelerometers. So of course, gyroscopes, accelerometers, they're in our phones. Basically, it's how a phone knows if it's tilted or not. So I use this device to tell the robotic landing pad like whether the ship is tilted or not. And then using information on how tilted the landing pad or the boat is, it tells the microcontroller, which a microcontroller is basically a small programmable computer. It tells the microcontroller the value it measured, and then the microcontroller instructs motors to rotate the particular axis that needs to be rotated, whether it's the pitch axis or the roll axis. Okay. So of course, you have your high-level view of the how the electronic parts connect here, but of course, you do need to generate the electronic schematic diagram for it. This is quite important to learn as well. For UP, the class was called Triple E1. I don't know if that's still the same, but I'm sure for all our student listeners, like we all have introductory electronics classes. So I highly suggest if you want to get into this field, like to pay particular attention to that one as well. It would be quite helpful when you moving forward. Right. So when you have the concept down, you want to mash up a prototype as quickly as you can. So I combined all of this and I made a small scale model of the landing pad. So here it is. I just use standard parts and then I attach smaller servo motors, and you can see the Arduino here and the sensing electronics here. So the good thing about electronics and software is that they're easy to scale, or they're irrespective to scale. Like the program I write for this and the electronics that I use for this, I can easily transfer it to the full scale system. So there's a lot you can learn from a small scale system. So it's always good to start at this point. So eventually, after finishing this implementation, you do want to test it out. So here's a very early stage of me testing the landing pad. So I was moving the base, and as you can see, the robot attempted to keep the box on top of it. So it stayed flat. So at this point, the client and I felt that the idea was viable. So it's at this point that you want to get into the math of things. It's when you want to start to do simulations or designs for the larger scale implementation of the robotic system. So for that purpose, I went into the full scale design of the system. So again, this is the landing pad done in SolidWorks. I started off with the the statics of it. So I'm sure a lot of us are familiar with this. It was very simple. I just did a stress analysis of the frame. It's an aluminum frame. I just made sure that it wouldn't break when a 6-kilogram drone would land on it. And you do a simple bending moment induced stress analysis on it. So what was that again? MY over I was it? Yeah. So you just check out for that one and see that it's way well below the maximum tensile stress of the aluminum that you're working with, or aluminum rather. Yeah. After the static aspects, we're going to be dealing with moving parts. So this is where the dynamic aspects come in. So this is where SolidWorks became very useful. So in SolidWorks, you can simulate motion. So I modeled the landing pad in SolidWorks and I simulated it. So basically, the client and I agreed that, okay, you want it to tilt in 25 degrees in both directions. So why don't you simulate it running, displacing 50 degrees from 0 to 50 degrees in about 3.2 to 3.5 seconds, right? So this green curve here is your position over time. And then the red curve here is your angular velocity. Based on the time range and the displacement range given, you would need a maximum angular velocity of 4.47 degrees per second. And then, of course, if you're dealing with masses, right, you need to accelerate them. Of course, dynamics comes in, kinetics. You do need a torque for that. So my simulation program told me that I needed a torque of about 8 Newton meters to be able to achieve this motion profile of the landing pad, right? It's very important to do simulation as much as you can so you can make informed decisions before you buy parts. So you don't want to just buy random motors, buy random bolts, buy random metallic parts for your robots. You have to predict as much of it as you can, like calculate as much as you can so you can make an informed decision. So basically, I narrowed down my choices to 3 viable servo motors. So obviously, if you look at the graph here, the table here, this last motor here can meet the requirement of 8 Newton meters because it can have a stall torque of 10.78 Newton meters. But okay, on side note, stall torque, as we all know, is when a motor ceases to turn. So basically, it's the maximum torque that it can provide. But the problem is, if you look at it, this motor costs way more than the other motors. And it's actually running too fast for what you need. So as an engineer, you don't, as a robotics engineer and as an engineer in general, you don't just look for solutions that work. You also look for solutions that are optimal. You want to minimize costs and you want to be efficient as to how you use your resources because these are limited when you work on a project. So in the end, I opted to use the D950 TW servo because as we all know, power is equal to torque times angular velocity. So you can treat the D950 TW runs fast and it has low torque. So you can simply do a gear reduction to reduce its speed, but to increase its torque. So this is where it got quite exciting because it's where you really get to apply mechanical engineering concepts to a traditionally comp-sci or electronics field, right? So you use a gear reduction for it. And then there were several gear reduction solutions that were available, but 3:1 to 7:1 worked fine. But why did I choose 5:1? This is where simulation was important again. The 5:1 ratio, I graphed it out here, the torque to speed function slopes. Basically, it shows how fast your angular velocity decreases as your torque increases. For this particular project, I wanted to find a gear ratio whose slope is similar to what was simulated in that earlier snapshot that I showed you. So this is the simulated slope, and this is the slope of the 5:1 ratio. So it has the most similar slope. So I figured it's going to behave closely to what I simulated. So let's go for this particular gear ratio, 5:1. And then you might be wondering, why is it all the way here to the right? But my requirements is here. That's all right. When you're working with motors, you just reduce the voltage and you shift the curve to the left and it will align. Then you'll be okay. Right. So now to the fun part. After all of your calculations, you've justified why you're gonna buy these motors. You've justified why you're going to buy this aluminum channel or these brackets with these particular cross sections. You get to order them and you get to build your robot. So this is the very early stages of me building up the landing pad. So this is the landing pad made of aluminum extrusions, and this is me mounting the motor with a gear reduction on it, right? After the mechanical aspect of the assembly, of course, you do want to get into the electrical aspect of it. So here I was testing the roll axis rotation of the landing pad, and here was the pitch axis rotation of the landing pad. So eventually, you combine all of these, and then you move on to optimizing your code. So Arduinos Arduino programs are written in C++. So it's quite a simple program actually for this particular robot. This code here handles the roll axis. This code here handles the pitch axis. This code here sends the commands to the servo motors to adjust the landing pad. So once that's done, you have the whole system ready and you're ready to integrate it all into the final robot or final mechatronic system. So here it is. So it's quite big. And then you're ready to test it. So here I am holding a model of the boat, a small boat. So if I tilt it, you see that the landing pad tilts or rolls in the opposite way. So it's at this point that you feel like, oh, okay, so what I designed works. So you'd feel pretty good about that. So yeah, so, but again, testing is also a key part of the R&D process. And it's not enough to visually observe how your robot is doing. It's also good to like check the graphs or like the numbers associated with it. So here, just for test purposes, I attached a gyroscope on the landing pad itself. And then with my system deactivated, I tilted the landing pad here about 20 degrees. You see that the deviation remains from 0. Basically, if these two lines are here, it means it's flat. Basically, that's what it means. And then I tilted it again, it remains deviated. But as you can see in the photo, with compensation in the GIF rather, with compensation activated, the system attempts to compensate once it's activated. So here I induce the noise, the interference to the system. I induce an angular deviation to it, and you see that the robot drives it down to 0 by adjusting the servo motors. So it's really cool because in UP I had this class called ME176, ME177. It's about control systems. So if you can notice here, there's actually a point for improvement. And it's when you really do your testing right and you really delve into the results of your tests, you get to see where you can actually improve your solution or your robots further. So you can see here, there are oscillations. So it says that there's like the system is unstable at certain points. So as you can see here, if you turn the heavy axis, it tends to like bend a bit because there's elasticity inherent to the system. That's what's causing these oscillations here. So moving forward, if I were to improve this project further, my main goal would be to move from an under-damped response of the system to a critically damped or over-damped even response of the system, so that you get rid of the oscillations. And of course, to get rid of those oscillations, you need to add damping. But again, that's just a point of improvement. So there, in the field of robotics, R&D, it's really a process of starting small, verifying your concept, and then improving it continuously until you get something that works well enough for your client's needs or to address the problem. So basically, that's it. That's my talk on robotics and mechatronics engineering. I hope you guys were able to pick something up from it. And here are my contact details. If ever you have any questions for me, and I also have a website if you want to see the other works that other robotics projects that I've worked on. So thank you very much for everyone's time. Yeah.
So, wow. Thank you so much, Engineer Luz, for that interesting talk. And actually, I think it's pretty comforting to learn that you don't need to be good at programming yet to enter the robotics industry. So you can still learn that later on. Like, you don't have to learn, you won't learn everything in school. So I think it's really good to hear.
Medyo medyo weird din pakinggan na nababanggit yung mga subject na ite-take / mga tinake mo. So that was something.
Yeah, when
Pero
it's like,
yun,
oh, do you understand this? And just like, it seems familiar.
tama. We'll get back to it. Pero yun, now we are sure that everyone has tons of burning questions for Engineer Luz. So make sure to use our Menti.
All right. So as you know, go to menti.com again and type in the code 41150522. Let me repeat, 41150522 to ask your questions. But before we proceed, we would like to once again thank our sponsors and partners. So see y'all in a bit. NMESC 2022 is presented to you by Philippine Society of Mechanical Engineers, University of the Philippines Student Unit.
Co-presented by Prime Mechanical Engineering Review Center, Zion Studios PH,
Brought to you by Davies Paint Philippines Incorporated.
our media partners, SparkUp,
Our community partners: Bataan Peninsula State University Society of Mechanical Engineering Students, Junior Philippine Society of Mechanical Engineers Cavite Chapter, Junior Philippine Society of Mechanical Engineers de La Salle University Dasmariñas, Junior Philippine Society of Mechanical Engineers Don Mariano Marcos Memorial State University Bidlo Union Campus Student Unit, Junior Philippine Society of Mechanical Engineers Emilio Aguinaldo College, Cavite, Junior Philippine Society of Mechanical Engineers Maragondon Branch,
Junior Philippine Society of Mechanical Engineers Polytechnic University of the Philippines Alfonso Campus, Junior Philippine Society of Mechanical Engineers USTP Chapter, Junior Philippine Society of Mechanical Engineers Xavier University Chapter, Philippine Society of Mechanical Engineers Technological Institute of the Philippines Student Unit Manila, Philippine Society of Mechanical Engineers Technological University of the Philippines Student Unit, Philippine Society of Mechanical Engineers Camarines Norte State College Student Unit,
Philippine Society of Mechanical Engineers Colegio de Muntinlupa Student Unit, Philippine Society of Mechanical Engineers Bicol University Student Unit, Philippine Society of Mechanical Engineers Lyceum of the Philippines University Cavite Student Chapter, Philippine Society of Mechanical Engineers National University Student Unit, Philippine Society of Mechanical Engineers Pamantasan ng Lungsod ng Maynila Student Unit, Philippine Society of Mechanical Engineers Pangasinan State University Student Unit,
Philippine Society of Mechanical Engineers PUP Student Unit, Philippine Society of Mechanical Engineers Sorsogon State University Student Unit Sorsogon Chapter, Philippine Society of Mechanical Engineers Tarlac State University Student Chapter, Philippine Society of Mechanical Engineers University of Batangas Student Chapter, UP Geodetic Engineering Club, and a special thanks to UP Mining Metallurgical and Materials Engineering Association Incorporation.
All right, we're back, and we'd like to thank again our sponsors and our partners. Now we move on to answering some of your burning questions with Engineer Luz. And this is our first question. What would you advise someone who is worried that they don't know enough to take on a path in robotics as a mechanic student?
Okay. All right. Granted, robotics seems overwhelming at first because mechanical engineering itself is a hard course to take, and then you're gonna add electronics and comp-sci into it. But it's not to say that robotics is 3 times harder than mechanical engineering. You do have to learn new things. But my best advice for you would be to take things one step at a time, learn small concepts first, and build your way up so that you can learn robotics. You don't need to take a course in mechatronics or robotics to learn about the industry. Like, my top suggestion for you now is to buy an Arduino starter kit. Like, it's gonna introduce you to electronics and embedded systems programming, and then from there, you're just gonna get inspired to build more things. And maybe that's the second part. Just like think of a robot that you want to build or a problem that you want to solve, and then just focus on that and just think about the things that you need to learn about to build a particular kind of robot. Because maybe a big part of robotics that I don't completely grasp yet is deep learning and AI, but it's not needed for all robots. Like some simpler robots can do without it. So take things one step at a time, buy an Arduino starter kit, and think of projects that you want to make, no matter how small.
Okay.
Thank you for that. Next question po muna natin is, do I need to study artificial intelligence if I want to be a robotics
Oh.
engineer?
Okay. I would say you don't have to go too deep into it, because in industry, like if you really want to go deep into artificial intelligence, I think that's more of in the domain of a computer scientist. But if you're a robotics engineer, you're going to go a bit wide. You can't afford to over specialize in one thing, and going really in depth with artificial intelligence might make you forget about the other parts that make up a robot. So there's the mechanical aspect of it and the electronic aspect. So it will help if you study in artificial intelligence, but just study enough of it for the application that you need. And a big for me, the most important application of artificial intelligence for robotics for me is computer vision. Basically, it's how you train robots to recognize things like how do you teach it to know that this is an apple or this is a person? That would be the most critical aspect of that. Sorry, is it okay if I share my screen for this one?
Oh yeah.
Will that work? All right, I'll just make it. Sorry about that. Okay. All right, thank you. All right, so let me just. So like here's a robot that I built for to practice artificial intelligence. So this is a face tracking robot. So this is the most useful application of artificial intelligence for me in the field of robotics. So basically, I trained the robot on how to recognize my face and then command a motor to have the camera follow my face. So for anyone's information as well, the programming languages I use for this is Python and C++. So those are worth looking into as well as something to study in addition to what you're learning in mechanical engineering. So yeah, that's it for that. Yep.
Okay. All right. AI. Okay, so I think we can move on to our next question.
Yeah.
Thank you for that, sir. Oh, this is a bit of a interesting one. It's about Baymax. So, sir, do you think Baymax from Big Hero 6 is possible, or like in general, like what are your thoughts about like robots in pop culture? I believe that's what he's asking.
That's a good question. I think robots like Baymax are quite possible. I think Baymax was designed to. Okay, when you think of a robot, you think of this combination of metal. It doesn't really look friendly. But there are robots out there, especially in countries like, I don't know, Singapore, Japan, where they make them more human-like or make them more cute. Because as we advance in technology, we're seeing robots move from to be seen in everyday life. Wouldn't you want them to look more approachable? I think that's what they did in Big Hero 6 with Baymax. They made them look approachable and more human-like. As for the mechanics of it, Baymax, I think he had the metallic skeleton on him, inside him, and then just inflated this whole fabric around him, something like that. There's this concept, emerging concept in robotics called soft robotics, where you build robots out of components that are not always rigid. So Baymax is not made out of rigid components, right? Like a lot of the stuff we study in our strength of material classes, or in statics or dynamics, we assume that they're not deflected or they don't bend. They're rigid bodies. So it's a challenging subspecialty of robotics, like being able to design someone like Baymax, because it's like soft robotics. But in general, building robots that interact better with humans and look more approachable and all of that, it's definitely happening now. Like, I don't know if you guys have seen in the news, but Jollibee and BGC has a robot employed in it. It delivers the food to the tables. Yeah, and a lot of hotels in Japan, they have robots in their reception halls or in their hotel lobbies, and they handle check-in for you. So in that aspect, it is becoming more and more realistic and actually necessary. Yeah.
Yeah, thank you for that, sir. Siguro next is from our talk yesterday, kasi na-discuss on 3D printing. They are asking, have you tried 3D printing on your projects?
Yeah. I haven't used 3D printing in any of my projects. What I've actually used is a simpler form of automated manufacturing called 2D laser cutting. So basically, for some parts of my prototype, I used a programmable laser cutter, X and Y axis, to cut a plastic sheet for some of my parts. 3D printing, of course, as you all heard in your talk, is an additive process, so it's way more complex. I haven't had to use it, but I expect that I'll need to use it because perhaps what you've gathered from the talk on additive manufacturing, it's advantageous as compared to subtractive manufacturing, which generates more waste. And it's more expensive to mill metal rather than to print in plastic. And as I mentioned earlier, it's very important to test concepts as rapidly as you can. And if you have to wait for a workshop to produce your parts out of metal and you're going to spend so much for it, it's not going to be viable. You're not going to be able to make anything. So thank you for asking that question. I think it's good for you to get comfortable with 3D printers. That's something I should catch up on definitely, and something whoever wants to get into this field to learn, because you can easily build prototypes with a 3D printer. So definitely relevant to the field.
Okay, thank you so much for that, sir.
Yeah.
And moving on to our next question. So, how is the state of robotics and automation in the Philippines when compared to other countries like Japan?
Good question. Okay. I haven't really looked into the numbers of this, but I think we can safely say that labor costs in the Philippines are quite cheaper than it is in other countries. Like minimum wages in other countries like the US, Germany, Japan, they're way up there. They're way higher compared to what our workers here get, sadly, right? But that means that since wages are lower here, I guess what happened was a lot of multinational manufacturing companies, like the ones I work for, Kian's, SunPower, and a lot of automotive companies, Toyota, Honda, whoever, they offshore their manufacturing here to the Philippines because labor is cheaper. Like, why would you pay someone times 5 the cost of what a worker would get if they could offshore it to another country? So there are a lot of industrial parks here and a lot of industrial complexes here in the Philippines where manufacturing is important. For mechanical engineers in UP, and I'm sure other universities as well, we've actually had to tour several of these plants to see some manufacturing processes. And what I think happened was, since these manufacturing plants were already set here, although they started out with people, eventually as technology improved, they moved on to robots. So with that regard, robots are prevalent here in the Philippines, but I think only in the manufacturing sector. There's room for growth in other sectors, like where I recently worked, the warehousing sector, and we are not at the same level yet as other countries are with service robotics, like the ones in the hotels, in restaurants, and I think a particular application that I think will be important for agricultural robotics. We're not yet there because I frankly think it's not yet needed at this time. But eventually, as people move on to other jobs, as the population ages, it's something we'll need to consider. And luckily, at least we'll have other countries to pattern off this technology on. Yeah.
Okay. Thank you, sir. Our next question is, May robotic simulation software po ba for students na pwede nilang pag-aralan without buying the kits?
Without buying the kits. Okay. Let me think about that. I haven't really used any robotics simulator programs, but I think there are some that are available. I'm just not sure how they work, but I think you'd have to integrate them sa Python or sa MATLAB or the free version of MATLAB, which is Octave. So I haven't really tried those out, but I encourage you. Okay, simulations are good, but again, our main advantage as mechanical engineers is we understand the physical aspect of it. So go for simulations, that's fine, but I really encourage you to get an Arduino. An original Arduino would cost around 1,500 pesos or so. It's because it's made in Italy, but it's open source, so a lot of smaller manufacturers can actually copy it. So you can get it off Lazada for 250 to 300 bucks on that website. And then like you don't even have to like just buy it for yourself. Like you can start a small club, like you all share one Arduino and learn it together. I really recommend going for an Arduino first, and for the simulation, yeah, you're gonna have to look that up online because I can't really recommend any particular ones now. Aside from simulating mechanics on SolidWorks and Fusion 360, I think that would be useful already in itself.
Okay, thank you so much, sir. And moving on to our next question. This is actually related to one of our inspirational speakers yesterday for the future entrepreneurs of the Philippines. If I were to start a business in the robotics industry, what would you advise?
Okay, that's a good question. If you were to start a business in the robotics industry, no? Okay, first thing I think you should do is look at what other countries are doing. Look at which robotics companies are successful abroad. If they're successful abroad, doesn't that mean results speak for themselves? If it works abroad, perhaps it can work here, right? Then the second thing you should do is like check if you can compete. Like, will it make sense to spend capital on buying robots, and will it save you in the long run for the reduced labor that you'd have to let go of or not hire in the first place? And third, as to what you will address, I think it's good to think about personal problems that you're having. Like, for example, like I hate doing the dishes, so I'd love to design a robot that could do my dishes. That's not a dishwasher, for example, or do the cooking for me. There are robots that can cook burgers, mind you, in the US. So basically that's it. Look what works in other countries if it doesn't exist here. Second, check if it's economically viable. So it's like a feasibility study. You're always comparing the capital cost of buying robots or doing them versus the savings in labor that you'll have to hire less people and see if the productivity gains are worth it. And then third, look at everyday problems. Like I'm trying to make this a habit where every week I just sit down and I think about 3 problems I want to solve. Not that I solved any of them so far or a lot of them, but maybe some of you will. And I think just listing them down, like what do I want to solve in the world? And then you're gonna come up with a robot that could address that problem. So yeah, basically that's how I would go about it.
Sir, our next question is, sige. Do you really need to go abroad to study robotics? Yan.
Definitely no, you don't have to do that. But it's also a good experience to go abroad to study robotics or to go abroad in general to learn about new cultures. And sometimes it's advantageous because the technology might not be here and it's there. But here in the Philippines, I mean, we have ComSci, ECE, mechanical engineering courses. But honestly, I don't know of any school that teaches particularly robotics. But maybe in the near future, someone could do that. And if no university offers it, I think it's perfectly fine if you self-study the topic. Like engineering, any field of engineering is technically complex. If you survive this mechanical engineering course, like as you are now, you can definitely learn things on yourself. So that would be fine. free content online, watch YouTube videos, buy books online for your Kindle to learn about the topic. That'll be fine. Like also be open to taking a lot of us, so we're taking a bachelor's degree. Make it, maybe if you have some free time, you can also take like short courses on mechatronics, like for technicians. Like usually in a factory, it's like engineers leading technicians, and technicians usually take these vocational courses. But I think it's also good to consider taking these courses on the side, so you can learn more about mechatronics, because there are a lot of vocational mechatronics courses, and that's going to be informative, very informative as well. And then at least when you go into industry, like you'll also understand what technicians are talking about when you're their engineer, and that would be good. They'll feel like, oh, this guy knows what he's talking about. He gets his hands dirty. I want to be led by this person. So yeah, you don't need to go abroad. It helps if you can, go for it. But if not, you'll have the resources that you need here, whether through vocational school or through self-study. And hopefully, I hope some of our universities, whether it's UP, Salle, whoever, hopefully our chairs or whoever handles it would consider putting up a course focused on robotics, because I think it's quite important. It's getting quite important already. Yeah.
Okay. Thank you so much, sir. And let's give sir a bit of a breather first. I just like to remind everyone that this merch is available. So if y'all want to buy, please look at the description or the caption. The link's right there. So please buy a new shirt. And okay, I think we can now move on to the next question. Oh, this is a bit of an interesting one. It is, hi, sir. Are you currently engaged? Or have engaged in construction related to robotics, local or international? And if yes, how is robotics entering the construction scene?
Okay, that's a really good question. Construction, they say, is difficult to get into for robots. I won't share my screen already because I might complicate the presentation now. But if you can see there in that graph, the construction industry is quite low in where robots can act in, because the environment is quite unpredictable. But actually, I just read up about this company in Japan. I think it's called DeepX. You can look them up. Basically, they take old, what do you call that excavator? An excavator, the one with the crane that goes like this. Yeah. Basically, they take old excavator and they integrate AI into it. So the AI controls the excavator by itself by checking the angles between the linkages of the excavator in order to dig properly. So that's the only key, one of the few applications I've seen of robotics, and I think it's in the very early or R&D stages. Another good application, now that you mentioned it though, I would see in terms of the construction industry, what would be helpful for that would be exoskeletons. So exoskeletons can be they're a mechatronic device. I'm sure you guys are familiar with that. It's basically a robotic suit that they put on you to amplify your strength. So in the construction industry, I would think this would have the most utility, because workers, they carry a lot of heavy stuff all throughout the day. And if you had like some sort of exoskeleton to carry that load for you that you just put on, there are a lot of exoskeleton companies. By the way, like in the US. It's just that I don't think anyone develops it here, so we don't really see it that often. But for the construction industry, those two might be it's not as prevalent, but those are the two emerging applications for the field.
Thank you, sir. Next question is, have you tried biomimicry in one of your projects?
Biomimicry. So just to share, if my understanding is correct now, biomimicry is when you design robots that take inspiration from life, right? I just want to share a bit more about that. This is a really cool concept, because why do you have to design something from scratch yourself when evolution already designed it for you? That's why this field of biomimicry makes sense. It's something I haven't applied to any of my robotics projects, because maybe my two key robotic projects was the AMR, so it uses wheels. So I don't think it's really necessary to use like a walking robot for that application. Like wheels are just effective for that. And the landing pad, it doesn't really need to move. It just tilts about its axis. But yes, biomimicry is important for certain fields, especially maybe for agricultural or military robotics, where you have to move through rugged terrain. Again, don't overthink like how you design the legs of your robot, look to nature because nature already designed it for you. So in those fields, biomimicry would make sense.
Okay, sir. Thank you for that. And I believe we do have time for two more questions. So, this next one's a bit controversial. So, sir, with the rise of automation, how do you think introducing robots into industries such as manufacturing will affect employment and job opportunities? Like, how factory workers could be affected by the rise of automation.
Right. Okay. For some industries, yes, sadly, introducing robots into a factory will reduce the workforce. But there are also studies that have been done, like particularly in the automotive industry, where introducing robots actually creates more jobs. And this is particularly important for collaborative robots. Collaborative robots are not totally isolated. Like these robots tend to work well with people side by side. So collaborative robots could actually increase employment. But yes, the fact remains automation in general could cut some jobs, right? And sadly, it's an economic thing at the end of the day. If you like for example, the AMR system that I talked about earlier, the manufacturer claims that productivity can increase twice or thrice. So that kind of implies that you can reduce your workforce by 50% or 66%, right? So if you think about it this way, so you do reduce the staff, but if robots improve the overall output of the plant, you can produce cheaper goods. And that means like it's kind of a greater good kind of thing for society as a whole. Like if you need to pay less people, you can produce products cheaper, you can serve more people. As for the 66% who got cut off, I'd like to think that the companies that do lay them off, like they have a plan for them, like a retraining plan for them. Because although robots are good at doing things, they can't do everything. Like there's still some things that only people can do, and hopefully like these people who do get laid off get to find those things. And I hope that the company that lays them off helps them to achieve that. At the end of the day, also, I think we can't really forego the concept of adopting technology or robots in general if I were a plant owner. Because for example, okay, I'm gonna care about my people. I'm like, okay, I don't wanna let anyone go. Not gonna hire any robots for my manufacturing plant. But robots at the end of the day are also more precise than people. They are not subjective, they're objective. They produce parts better, they make parts better. So what happens to my company if another company produces the same product in another country and they have robots? They produce better products than me. My factory closes. The people I hired still lose their jobs. So there's actually a balance to it, I think, that anyone who wants to build a business built around robotics, there's a balance to it about how many people you want to get and how many robots you want to get and what it would mean for the employment situation in the Philippines. But in general, I think also there should be a body that like takes care of these displaced workers who are affected by automation, because as you can imagine, these workers do repetitive things in the plant, but like I think this can be an opportunity for them also to explore new career opportunities. As difficult as it might sound, but hopefully they could get retraining for that purpose. But that's what the situation I think regarding robotics and employment, basically. Yeah.
Okay. Thank you for that, sir. Very beautiful answer. And for our last question, we have: where do you see the robotics and mechatronics industry in the Philippines 10 years from now?
10 years from now, where I'm seeing it going and where I'd like to see it go is we see more robots outside of factories. Like, I think given that I think we've already saturated the factories, so to speak. Like, I mean, there's nothing new there. There's no more need to develop new robots for factories. Perhaps in a few years, as our farmers get older, maybe more people move into the cities. We have less people handling those farmlands. We might see more robots working outside of the factories. I think my guess, maybe we'll have agricultural robots in the future. As for service robots, like robots in hospitals, restaurants, or hotels. I don't think it's gonna take off as much here in the Philippines as compared to other countries. Um, so yeah, that's where I think it's at. More robots outside of the factory. I'm guessing particularly in the agricultural sector. Yeah.
Okay, so thank you for that so much, sir. And with that, I think we've taken up all of our Q&A time. I really want to ask some more questions, but the show must go on. So again, thank you so much, sir. And yes, I believe it's time to award the cert. Gab, what do you think?
Yes. And we hope that everyone learned a lot from Engineer Lou's talk tonight. And sure, pareho kami ni Ram. We both
Yeah.
did. And ang daming insights, the valuable insights that came from him. So I hope kayo rin natutunan yun. With that, we would like to call upon the NMESC 2022 co-head Paul the Shadow Sim to award our speaker with a certificate.
Wait, go na ba? Okay. The Philippine Society of Mechanical Engineers, University of the Philippines Student Unit awards the Certificate of Appreciation to Engineer Christian Alexis Luz for sharing their knowledge and expertise on robotics during the National Mechanical Engineering Students Convergence 2022, given this 20th of September 2022.
Thanks, guys. Thanks, guys.
All right. And that is the end of day two NMESC 2022 Crank Up. Thank you so much for attending, and we hope that everyone learned a lot today. I know I did, Gab did, and yep.
Yes, and don't forget to answer our feedback form in order to be able to claim your certificates of participation for this event. The link is posted in the comment section and will be open for, again, 1 hour only. So make sure to answer as soon as you can, and make sure that you also answer our raffle form, which should also be in the comment section to join a raffle event and get a chance to win an RK100 mechanical keyboard, Edifier XGS through wireless earbuds, or 500 pesos in cash.
And once again, I'd like to remind everyone that we are selling shirts once again, PIS merch. So the link should be in our Facebook caption or the description of our YouTube. And guys, just saying, the YouTube is still available, so y'all can just hop over there if Facebook is lagging. And yeah, I think that's all for me. Thank you so much for coming to NMESC 2022 Crank Up Day 2, and we hope to see you again. This is your host, Ram.
And this is your host, Gab, and we wish you a pleasant rest of the evening. Thank you.
See you tomorrow. Right. NMESC 2022 is presented to you by Philippine Society of Mechanical Engineers, University of the Philippines Student Unit.
Co-presented by Prime Mechanical Engineering Review Center, Zion Studios PH,
Brought to you by Davies Paint Philippines Incorporated.
our media partners, SparkUp,
Our community partners: Bataan Peninsula State University Society of Mechanical Engineering Students, Junior Philippine Society of Mechanical Engineers, Cavite Chapter, Junior Philippine Society of Mechanical Engineers, De La Salle University, Dasmariñas, Junior Philippine Society of Mechanical Engineers, Don Mariano Marcos Memorial State University, Bidlo Union Campus Student Unit, Junior Philippine Society of Mechanical Engineers, Emilio Aguinaldo College, Cavite, Junior Philippine Society of Mechanical Engineers, Maragondon Branch,
Junior Philippine Society of Mechanical Engineers, Polytechnic University of the Philippines, Alfonso Campus, Junior Philippine Society of Mechanical Engineers, USTP Chapter, Junior Philippine Society of Mechanical Engineers, Xavier University Chapter, Philippine Society of Mechanical Engineers, Technological Institute of the Philippines Student Unit, Manila, Philippine Society of Mechanical Engineers, Technological University of the Philippines Student Unit, Philippine Society of Mechanical Engineers, Camarines Norte State College Student Unit,
Philippine Society of Mechanical Engineers, Colegio de Muntinlupa Student Unit, Philippine Society of Mechanical Engineers, Bicol University Student Unit, Philippine Society of Mechanical Engineers, Lyceum of the Philippines University, Cavite Student Chapter, Philippine Society of Mechanical Engineers, National University Student Unit, Philippine Society of Mechanical Engineers, Pamantasan ng Lungsod ng Maynila Student Unit, Philippine Society of Mechanical Engineers, Pangasinan State University Student Unit,
Philippine Society of Mechanical Engineers, PUP Student Unit, Philippine Society of Mechanical Engineers, Sorsogon State University Student Unit, Sorsogon Chapter, Philippine Society of Mechanical Engineers, Tarlac State University Student Chapter, Philippine Society of Mechanical Engineers, University of Batangas Student Chapter, UP Geodetic Engineering Club, and a special thanks to UP Mining Metallurgical and Materials Engineering Association Incorporation.